Okay, so let's get started. So good evening everyone. Okay, so in the last class we saw maximum likelihood estimation and we touched upon logistic regression. So are there any queries relating to these topics? We'll do a brief recap of what we covered, and then in this week we will move on to confusion metrics, receiver operating characteristic curves, and we'll touch upon like basics of analysis of logistic regression model, and we'll see some examples in Python. So any queries so far? Okay. Yes. Saravanan, you have any query? Yeah, I'll be sharing the collab notebooks with you. Like if you go to my if you go to my YouTube channel, so in the video description, just a second, let me just share that. So if you go over here, in the description you will find a link, and in this link this is a link to the folder where I am uploading all the material. So since we are running like 1 week behind the schedule, so I'll be uploading the week 9 Python notebook and the slides over here by tonight after the session. Okay, great. So let us do a brief recap of what we did last time. So in the last class we saw maximum likelihood estimation. So can anyone just briefly mention what exactly maximum likelihood estimation is? Like what do we use it for? Let's say we have been given certain data points. So what do we use maximum likelihood estimation for? Any idea? Okay. So the purpose of maximum likelihood estimation is to estimate the parameters of a distribution, let's say normal distribution. So you want to find out the base normal distribution that fits the data given to you. And how do we do that? So we saw in the last class, we compute the likelihood of every point with respect to the distribution with unknown parameters, and then differentiate it with respect to the parameters and then equate it to 0 and solve the equations. So that's the simplest way to get the parameters estimation. Okay, and then we moved on to logistic regression. So let us quickly see like what we saw using this Python notebook. So I'm importing the necessary libraries. So here we are reading the Excel file in which we have data points x's and the y's, where x is the independent variable and y is the dependent variable. So we saw two ways. First is using OLS, like here we are trying to fit a linear curve on the given data points. You can do this using ordinary least square. Okay, let me just zoom it in a bit. Using ordinary least square method, the traditional method to solve any linear regression problem. So let me just fit this data over here, and you will get a summary table which will show you the significance of the estimated parameter, like estimated parameter and their individual significance, and also like the significance of the overall model. Now the condition for OLS and MLE, like we saw in the last class, like when do we prefer MLE and when do we prefer linear regression, so or ordinary least square. So we saw the constraints that need to be met for ordinary least square. Those were that the error term should be normally distributed with mean 0 and some standard deviation. If that's not the case, then in that case we use a general method which is maximum likelihood estimation. So in this case we are trying to see both the cases, like using ordinary least square as well as maximum likelihood estimation, and see like and conclude that both give the similar results. So here E is nothing but the residual, which is nothing but difference between the observed and the fitted values. And let us see the means and the standard deviation of the residues. So we have 5 data points over here, and for each of the data points you have this predicted values with respect to the line that you have fit, and the predicted value and the actual value that will give you the residue. So here we are computing residue, the mean and the standard deviation. So you can see that the mean value is very close to 0. Here e to the power minus 15, it means like it is very close to 0, almost 0, and it has some non-zero standard deviation. So it was okay to fit linear regression in this case, and then we can do similar kind of analysis using maximum likelihood estimation. Like we can estimate the parameters of the line equation using maximum likelihood estimation. So here we are defining this likelihood function, and then passing this likelihood and the initialization with some method over here. We saw this in the last class. It was some crazy name. I don't remember exactly what it was. Okay, let us see. It is some optimization algorithm which is used to minimize the likelihood, like negative of the likelihood internally. So yeah, so here you can see that the intercept value and the coefficient of x are exactly same as what we have estimated using OLS, and even the standard deviation of the residues you can find out to be similar over here. So to conclude, you can estimate the parameters of any distribution, be it linear regression model or normal distribution or Poisson distribution or any sort of distribution using maximum likelihood estimation. Ordinary least square is simpler actually and more interpretable compared to MLE for linear regression task, but MLE kind of is a general method that can be applied in any scenario for any sort of distribution. Okay, so this was all about maximum likelihood estimation, and then we moved on to logistic regression. So we saw an example in the case of logistic regression of a company which wanted to give some gift coupons to its customers, and then they had certain criterion based on which they wanted to make these coupons available to the customers. So they analyzed like the amount each of the customers spent in the last year, and they were checking if the customers were having the company's credit card or not. So based on these two criterion, they were giving the coupon. So if the coupon was allotted, the value of this coupon variable will be 1, else it will be 0. So let us quickly run this code and see. So here coupon versus spending is plotted. This is not of our importance, not of much importance to us. What is important over here is the function of spending and card. So let me just quickly share this on iPad, what we are trying to do over here. Okay. So in this case, let's say we just have one independent variable and a dependent variable. So independent variable, let's say it's pending, and the dependent variable is whether to allot coupon or not. So we have spendings and we have coupons, coupon allotment. So you can see this coupon allotment is having binary value 0 or 1. So if you plot spending versus coupon, you will end up getting something like this data points. Okay. Now fitting a line over here is not appropriate, right? Say we add one more variable over here, credit card. The values can be either 0 or 1, whether they have credit card or not. So based on this, allotment of coupon, so it will be in the 3D space now, these data points. So fitting a plane also won't be a feasible choice over here. So what we do now, once we have this, so we have two variables, spending and card. So we create an equation. We generally use small b's because these are estimates, not the population parameters. Let us call this as Sx. Now we transform this in such a way that given this as input, we will be getting the probability of getting the output variable equal to 1, that is probability of the dependent variable being 1 can be given as 1 upon 1 plus e to the power minus of Sx, where Sx is our plane equation and we are transforming it to a sigmoid function. So this is like using sigmoid function, we are transforming the input to probability value, which will range from 0 to 1. Okay. So now given the spending and the card availability, you can compute this Sx, you can give this Sx as input to this sigmoid function and get the probability, certain probability value over here. For example, let us say Sx is some value and its corresponding probability will be something over here. Okay. So for every Sx, so S1x, S2x, for different values of spendings and cards, you can have different values of Sx. Now this particular probabilities are continuous in nature, 0 to 1. So whether to decide to give coupon or not, you will have to have certain threshold over here. So let us say threshold is at 0.5 probability. So if for a given Sx the probability is greater than 0.5, we will give that customer coupon, If it is less than 0.5, we will not give the coupon. So, is this concept clear about logistic regression, what we are trying to do over here? Anyone? If it is not, I'll repeat, because this is important for our further analysis on ROC curve. Okay. So, if it is not clear to anyone, please feel free to ask. I am here to explain it to you. Okay. So, this was about logistic regression. Now, let us see a scenario. We have function of dependent variables x1, x2 and so on, which is nothing but Sx, what we were denoting earlier, and then probability. Okay. Before going over here, let me check if anything is left over there in the case of logistic regression. Yeah, so let me go back to Python notebook and then we'll come back over here. Okay, so here was an example. So we had this data of customers spending their spendings, card usage, or like the card availability with them, and the provision of coupon to them. So using this, we were trying to fit a logistic regression model on the data. So here X contains two columns, spending and card, and Y contains the values in the dependent variable, that is coupon. Now we are adding constant over here. We saw this in one of the previous sessions. Why do we add constant? It is because for the constant term in your line equation or the plane equation, that is B naught. Okay. So once you have this spending, card and a constant added, you pass on the dependent variable and the independent variables to this logit function, similar to what we did in the linear regression case, simple linear regression. In that case, we were having OLS instead of logit. So we are trying to fit in the logistic regression model to this data, and you can see the estimation of the parameters. So these are the values of B0, B1 and B2, and you can see the significance of each of these independent variables coefficient over here, and these are less than 0.05 if that is the significance level, and which shows that the model each individual coefficient is statistically significant. And the test that we use is Z test. It is also called as wall test in this particular scenario. And after that we saw this G test. So G statistic, similar to the F statistic in the case of linear regression, there F statistic was computed using MSR by MSE. Similarly over here G statistic is computed using two parameters over here, like two values over here computed using the model. One is log likelihood, that is taking the independent variable into consideration. Now we need to go into more details of how this particular log likelihood is calculated. So that is out of the scope of the syllabus, so we won't do that over here. But to give an analogy, it is similar to what we did in the case of linear regression. We had this MSR, right, mean square like sum of squares due to error like divided by degrees of freedom. So mean square due to regression. So once you were adding the independent variables, so your error was getting reduced, the error of estimation, compared to the null model, which was nothing but the y bar in the case of linear regression. Similarly, in this case, you have certain estimation or likelihood with respect to the independent independent variables into consideration and without independent variables, that is the null model. So here also you are trying to get the ratio of the null model and the model with independent variables into consideration, and then this particular formula will give you a G statistic which can be used to find the statistical significance of the overall model. So once you get this G value, you can find out the p value using this chi-square function in the scipy.stats module. So this particular G statistic will follow chi-square distribution. What was the distribution that was followed by the F statistic? Can anyone answer? The distribution that was followed by the F statistic that we computed in the case of linear regression, what was the distribution? Anyone? Okay, looks like everybody needs revision. So it was F distribution in that case with numerator degrees of freedom and denominator degrees of freedom. In this case, the G statistic is following chi-square distribution with degrees of freedom equal to the number of independent variables in the model. Okay. So this was about logistic regression. So now let me get back to iPad. So now you have logistic regression model. Somebody is asking, sir, why sigmoid can't be a ReLU? I don't have a direct answer for it, but I think why ReLU is not used. For those of you who do not know what ReLU is, okay, let me just show it to you. Okay. So do you see how ReLU looks like? So before 0, it's all 0, and after 0, it's exactly a single line with certain slope. Okay. Here it is given. So this is ReLU and this is sigmoid. So what problem do you think ReLU might be having? Anyone? Okay, I leave it as a question. You think over it, like what might be the problem with this ReLU function, like why we can't use it over here in this logistic regression scenario. Okay, so we'll discuss this shortly. So here is the case. Now we have a logistic regression model and you have certain data points. Let's say data points from class 1 which are having label 0 and data points from class 2 which are having label 1. Okay. So for each of these data point there will be a corresponding probability value. And so on. Okay. Now if we set a threshold over here, let's say at 0.5, so all these points which are beyond this line, sorry, not here, which are beyond this value will be considered as 1 belonging to class 1 because the probability is higher than 0.5 which is threshold, and all these data points will be considered as belonging to class 0. Okay. So what is the problem in this case? You see any problem over here? There are certain data points from class 1, these blue points, that are incorrectly getting classified as belonging to 0, and there are certain data points which are from class 0 and they are getting the label of class 1, and it is possible in real world scenario. We will discuss some examples. So is this part clear till now, like how we are trying to classify each of the data points using logistic regression model into one of the two classes? Yes, no, is it clear? What about others? Okay, great. So let's say we have this distribution of data points from the two classes. This is class 0 and class 1, and these are the test values, some test statistic values, like whatever, not test statistic, like some value based on which you were trying to decide whether the points belong to class 1 or class 0. So this is class 1 and this is class 0. So let us say threshold is over here. So all these points, let me highlight this, all these points from class 1 are getting correctly classified as belonging to class 1. Okay. So these are known as true positives or TP. Here we are saying 1 is positive and 0 is the negative class. So in this case all the true positives are, means all the positive values beyond this threshold are getting correctly classified as positives, so hence they are called true positives. Similarly, all these data points belonging to class 0 which are lying below this threshold are correctly getting classified as negative, so they are called true negatives or TN. And the data points that are lying over here, which are actually belonging to class 0 but getting classified as class 1, these are called as false positives because they are falsely getting classified as positives. And similarly, these data points are falsely getting classified as negative class, so these are known as false negatives. So we have 4 terminologies over here: true positive, true negative, false positive and false negative. Now having this, there are 2 terms associated. One is sensitivity and specificity. So these are the data points that are getting classified using some model. In our case, it is logistic regression. Okay, it can be any general machine learning model or anything, any classification model. Okay, so based on this threshold, we are classifying something, so like data points into 2 classes, and some of them are getting misclassified because of the threshold value. So there are 2 terminologies that are associated: sensitivity of the model and specificity of the model. Sensitivity says that how many of the true positives are getting correctly classified as true, how many of the positive class data points are getting correctly classified as positives. So what will be the expression for this? Can anyone answer? How many of these true entire blue data points are getting correctly classified as positive? Anyone? Please think over it. Okay, let me introduce one more thing to you before that. We can also represent it using a matrix called as confusion matrix. For 2 class problem, we will have 4 cells over here. Let us say we have actual here and predicted here. This may also change, like some people write actual over here and predicted over here. So it depends, but doesn't change the values over here. So we have class 1, class 0, class 1, class 0. So class 1 getting classified as class 1 are true positives. Class 1 getting classified as 0 are false negatives, zeros as 1 false positives, and zeros are zeros true negatives. So these are numbers actually over here, can be like 3, 6 and so on. So now can someone tell what will be sensitivity? So sensitivity says how many of the positive class data points are correctly getting classified as positive class. So it will be a ratio of something. So please try to answer. Anyone? TP upon TP plus FP plus Fn, not really. So TP is fine, the denominator will be all the positive data points. So all the positive data points are this blue ones, right, which is Tp plus this yellow points over here, points in this yellow region, Fn. So Tp divided by Tp plus Fn will give you the sensitivity of the model. Similarly, we have this term specificity, which says how many of negative data points are correctly classified as negative. So what will it be now? Can anyone answer? How many of negative data points are getting correctly classified as negative? It will again be okay, Tn upon Tn plus Fp. Yeah, that's correct. Tn upon Tn plus Fp. Okay, so why these terms are introduced? So let's say you have a scenario, you have two classes, you have a threshold, and this class belongs to person not having disease and this is person having disease. Let's say it's some fatal disease and it needs to be treated. So based on the tests that doctors do, like they will be doing n number of tests, based on that they may decide whether the person is having disease or not. Let's say you pass on the values of these tests, like the results of this test, into a logistic regression model, and it kind of classifies the person having disease or not. So if that disease is fatal, it needs to be treated, right? So in that case, it is expected to correctly classify patients having disease as having disease, like who are actually having the disease, they should be detected as having disease, because if they were not like if it is something like cancer and it is not detected, so it may become fatal at later stage. So it is important for it, the model to detect it at the earlier stages itself. Okay, so the expectation is that the model will be more sensitive to the disease, right? So cancer patient getting correctly classified as having cancer is better than the patient not getting classified as having cancer. So in that case, we change this threshold such that maximum number of patients are getting correctly classified, like who are actually having the disease are getting correctly classified as having that particular disease. So in this case, if we reduce this threshold over here or change this threshold over here, let's say this red line, so what will happen to Tp, Fp, Tn and Fn? Can anyone answer? You can unmute and answer or put it in chat. This was my earlier threshold and now I am changing the threshold over here. So how will my TPs, FPs, Tn and Fn, so which one will increase and which one will decrease? Yes, that's right, TP will increase, like all these data points will now get correctly classified as positive class or having disease. And there are these data points. So what will happen to FP? Yes, so FP is going to decrease. But now what is going to happen to TN, true negatives? So true negative values are getting decreased over here, and false negatives, oh sorry, false positive, true negative is decreasing, false negative is, oops, just a second, true positive is increasing, false positive is decreasing, true negative is decreasing. My bad, false positive is increasing, true negative is decreasing, and false negative is increasing. Is it clear? This particular thing over here is false positive, sorry, my bad. Yeah, Fn false negative, sorry. So this yellow thing over here is false negative, this dark blue color over here, it is false positive, this blue thing is true negative, and this is your, sorry, true positive and true negative. So as you are changing this threshold, TP values are increasing, TN values are decreasing, like this area over here is decreasing, Fn has decreased and Fp has increased. Is it clear? Is it clear, everyone? What about others? Yeah, this is important to understand. Like it's the diagram is a bit messy over here. Let me try to redraw it. Let's say there was this earlier scene and threshold was over here. You were having all these data points belonging to the first class or class 1 getting correctly classified as class 1, and this were like from class 2 getting correctly classified as class 2, and this were like data points from class 1 which were getting classified as negative. So this is like, let's say, positive class, negative class, and these were from negative class getting falsely classified as positives. So TPs, TN, false negative and false positive. So all the points over here are positive and all the points over here are negative. So these are the true positives and these are the false positives. These are true negatives and false negatives. Okay. So now what I was saying, I am changing this threshold, like the distribution will be the same. So the threshold is getting changed over here. So in this case, this blue color area is increasing, which means TP is increasing, this yellow color part is decreasing, which is nothing but false negatives. Tn is decreasing, and false positives are increasing. So what it means? So in the medical scenario, like if you are adjusting your threshold such that maximum number of uh, patients having that particular disease are getting classified as having the disease, that is more important in this case. So we expect the sensitivity of the model, which is nothing but Tp upon Tp plus Fn, to be higher when the disease is fatal, because it is better to detect the patient having disease. And in this case we are also having this particular thing that false positives are increasing, which means that the patients who are not having that particular disease are also getting classified as having the disease. So they may have to undergo further tests, so that is fine. But the problem will be when the person having disease is not getting detected, like if the cancer is not detected, so it will be fatal, like dangerous for the patient. So in that case you will have to adjust the threshold such that maximum of the patients having the disease should get classified as having the disease. Okay, so in that case sensitivity of the model should be higher. Okay, now this is one scenario. Can you give me another scenario in which you expect the negative class to be given more importance? This was in the case of disease. Can you give me one example? It's a very common thing that you come across every day. So can you think of some example in which negative class is given more importance than the positive class? Anyone? So what about email getting classified as spam or not spam? So email getting classified as spam is positive, and not getting classified as spam is negative. So in that case, how will you set the threshold? Okay, this is like 50-50. So will you set the threshold towards the negative class, like towards left or towards right?
Towards negative.
Are you sure?
Towards right.
Okay, so why towards right?
Because we want to increase the false true negative.
Yes, that is true. So here in this case you don't want to miss out on any important emails actually. Like even if you are getting spam email in your inbox, that can be okay for some time, like but in some scenario. But if you are missing very important email, like if that email is getting classified as spam and it's going to the spam box, so that is not expected. So in this case you are giving more importance to the negative class and adjusting the threshold accordingly such that this true negatives, that is the email not being spam, is higher. So here you are trying to increase the specificity of the model, that is true negative out of all the negative classes, maximum number of negative classes should be getting correctly classified. Okay, and we saw this same representation using this matrix called confusion matrix. Fine. So now the question is how to decide upon the appropriate threshold. Like for every threshold you will be having certain confusion matrix, right? So for this threshold you will have certain number of true positives, true negatives, false positives and false negatives. So as you change this threshold, you will have different values or different number of different values in the confusion matrix. So will you analyze all these confusion matrix like just by looking at them? Will it be feasible to do so? Like say I have 100 such thresholds, and for each threshold I am having a confusion matrix. So I am having such 100 such confusion matrices. Okay. So it is not feasible to analyze the true positives and false positives and so on using just the confusion matrices. Like so, to tackle this, we have something called as ROC, or also known as receiver operating characteristic curve, which is nothing but a curve for true positive versus true positive rate versus false positive rate. So true positive rate is also called as sensitivity, that is Tp upon Tp plus Fn, and false positive rate is actually 1 minus specificity. Which is Fp upon Fp plus Tn or Tn plus Fp. What is our specificity? It is Tn upon negative class values getting correctly classified as negative, and this is positive Fp upon Tn plus Fp, that is 1 minus specificity. So does anyone know the history behind this ROC, like receiver operating characteristic curve? So what this curve is, like it shows you for different thresholds what will be the true positive rate, that is sensitivity, and 1 minus specificity, that is false positive rate, for a given model. So let's say you have trained a model, logistic regression model, and you have some other model which will have some other like shape of ROC. We will discuss that later, but the question is like yeah, do you know about the history of this ROC, receiver operating characteristic curve? Okay, so in the World War II actually there were certain ships which were operated by people, and they were having this radar which used to detect whether a particular plane is of enemy or not. So every person used to do this, like in the radar it was important to see if the particular plane is enemy or is not enemies. So there were two classes. Okay, so based on the receiver operator will annotate every data point as belonging to one of these two classes, and obviously there will be certain misclassifications. They may identify enemy's plane as their ally, or their allies plane as enemies. So that might vary from receiver so this person was receiver operator, and the characteristics of every receiver operator might be different depending on the experience of the person. So to judge the characteristics, like to identify the characteristic of this each of these receiver operators, this receiver operator curve was made or designed. So what it shows, for a given false positive rate, what is the corresponding true positive rate? So if this is the case for one receiver operator, and let's say this is the curve for another receiver operator, so which one do you think is better? For a given FPR, like which curve do you think, or which receiver operator do you think is better, the green one or the blue one?
Green one is better
Yeah.
because it has less false positive.
No, false positive is fixed over here. False positive rate is fixed. What
No, I
is
mean for given thresholds, like after a certain threshold which you have marked, like
uh,
it's all true
uh,
positive.
it's not a threshold actually, it's some false positive rate, and for this false positive rate you have this two true positive rate. So actually every point on this curve
Hmm.
corresponds to a threshold, like
Right, right,
yeah, so
right.
for a threshold you will be having certain TPR and FPR. So let's say for a threshold you have certain FPR, and then for these two operators you have this TPR values. So question is like which one will be the better?
Still, the green one is better. Like,
Yeah, that is correct. The reason being that for this given FPR, the true positive rate is higher for this particular operator than the other one. So the chances of enemies plane getting correctly classified as enemies is higher for this particular operator than this operator. So this can also be seen from the area under the curve. So if you see this green curve and this blue curve, so the area under the curve for this green one is higher compared to this blue one. Okay, and higher the area under the curve, so the base scenario will be, how will it look like, the best curve? Any guess, like the best receiver operating characteristic curve?
maybe a horizontal line.
You mean like this?
No, at the top.
Yeah, so it will be like this.
Yeah.
So area under the curve is this entire thing, it will be 1. Okay, so how do we find this out? You have two classes, you set a threshold, you compute true positive, true positive, false negative, false positive, and true negative for this given threshold, and then compute this TPR and FPR, and plot that for that threshold you plot it on this curve. Then you change the threshold, let's say here, then you compute TPR, true positive, false negative, true negative again, and then you compute the FPR and TPR, or sensitivity and specificity. So this is sensitivity versus 1 minus specificity. So for each of this threshold you will be computing these two values, FPR and TPR, and then you will plot this values over here, which will look like this curve. It will change, the shape of the curve will change based on how well the model is, like how good the model is. So instead of receiver operators, here we are considering models like logistic regression or any other classification model like Bayes classifier or neural networks or anything. So this is used to identify the accuracy or which model is better in terms of classification accuracy. So for that, receiver operating characteristic curve is used. And like there is one more thing called DET curve, detection error trade-off, which is also similar to ROC, but like it let us not go into the detail of it. Like it is also used to identify the models which are better than the others, but one advantage of DET over ROC is that in case of DET, the if even if like two models are very close to each other, like in terms of classification accuracy, so in the case of ROC, the curves will be almost lying close to each other, whereas in the case of DET, you can see some separation over here. So it's not in your course, like it's out of the scope of syllabus, so I won't cover it, but it was just for your information. There is something called as detection error trade-off curves. You can look into it later if you are interested. So this was all about confusion metrics and ROC. So let us see some questions and then we'll move on to Python notebook. Okay, let me share a particular window, a tab. Okay. So which of the following is incorrect? True positive. Test states that you have a disease when you have it. We do have it. True negative. Test states you do not have a disease when you do not have it, and so on. Okay, let me start the poll. Okay, somebody answered over here. So false negative. Test states you do not have a disease when you do not have it. Okay. Yeah, so the correct answer is D. True positive is positive getting classified as positive. True negative is negative getting classified as negative. False positive is positive getting falsely classified as positive, like negative getting falsely classified as positive, and false negative is positive getting falsely classified as negative. So test states you do not have a disease when you do not have it. This is applicable for true negative and not false negative. So when you do not have it, that is negative, getting classified as negative is false, true negative and not false negative. So this is the incorrect option. Is it clear? Yeah. Okay. Statement: the outcome of a logistic regression model is a probability. True or false? Okay, what about others? Fine. So we saw that that is true. we saw like logistic regression, it takes independent variables into as input, finds out a plane like or a line if it is only one variable, or a plane or hyperplane in multi-dimensional space, and then we give that as input. Okay, let me just show it. Yeah. So I was denoting Sx as the equation of the line. Sx here is denoted as a sigmoid function itself. So the equation of line or plane, whatever you were computing using your independent variable, you will give it as input over here to the sigmoid function and get a value between 0 to 1 which represents the probability. Okay. So this, instead of x, we are passing some equation over here like beta naught plus beta 1 x plus beta 1 x1 plus beta 2 x2 and so on, which is like linear combination of multiple independent variables, and then you are trying to find out probability of this particular variable or independent variable having this value 1. Okay. Fine. So specificity in ROC analysis is defined as okay, that's correct. So how many of true negatives are correctly getting classified as negatives? Okay, next question. Area under a ROC curve and ROC curve actually have a maximum value of 1, which is known as perfect prediction. Okay, many of you got it, so that's true. 1 means 100%. Which of the following factors affect selection of threshold in ROC analysis? Cost of failing to detect positives, cost of raising false alarms. False alarms are nothing but false positives. Both A and B, and none of the above. Okay. Yeah. So the correct answer is both A and B, because you need to take into consideration both these things, like cost of failing to detect positives, that is false negatives, and cost of raising false alarms, that is false positives. So depending on the problem at hand, you need to decide threshold based on this values of false positives and the false negatives. Okay. In regression analysis, the model in the form of y equal to b naught plus b1x plus e is called. Okay, many of you are answering A. The correct answer is actually regression model and not regression equation. This is a model actually. So that's the terminology question. So it is called as model.
Yeah, actually, y cap is a regression equation.
I see. Okay.
This one is having B only, na? Beta 0 and beta 1 should be regression model, right?
Uh,
No, no. Actually, y cap should be or y hat should be regression equation, I guess.
okay.
This one is for a regression model. Uh, I mean, y is equal to simply y is equal to this is the regression model, whereas y hat should be regression equation. Na?
Uh,
There
yeah.
is a regression
Yeah.
equation.
So okay, this terminology even I am not very confident on it. Like okay, we'll get back to this maybe in the next session. I myself will confirm this, like what exactly regression equation and regression model differences. Okay. Yeah. So let us move ahead. Suppose you are testing two models that detect whether or not a person has cancer. You obtain the following values for sensitivity and specificity. Which model would you prefer? Saravan, actually y hat it represents the estimated value using your estimated line equation.
Yes, yes. Estimated is that. I mean,
Yeah,
y hat is estimated.
yeah. Okay, so what will be the answer for this? Okay, any reason like why?
Yes, sensitivity is more, and one minus specificity that is on the x-axis when you so that analysis one minus TNR. So specificity is 0.81 means one minus specificity is less. So that will be above the
Not really.
normal.
Like if you see, if you just go by specificity alone, so 1 minus
Yeah,
specificity will be lesser in the second case.
but sensitivity is also
Yeah,
less, na?
sensitivity is less. Yeah, so that is important over here.
Yeah.
So when you are dealing with cancer, you have to have true positives. Like the person having cancer should be correctly classified as cancer. Hence, the model's sensitivity, that is true positive divided by true positive plus false negative, should be higher, and hence model A is preferred in this case. Okay. What can you infer from the point on the ROC curve over here, 1 1, which is corresponding to 1 1? Any inference from this?
That the observation is true positive and it is positive, like.
So if it is 1 comma 1, x-axis is 1 minus specificity. So 1 minus specificity is 1,
Mm.
which means specificity is 0.
It's so it's not negative, it's positive.
Okay, let me
No,
explain
no,
it.
it's good, na? Actually, it's good, but to
Okay,
what extent it's good, I don't know.
okay, let me explain it to you on iPad.
No, 1 minus specificity is 1 means specificity is 0. So
Yeah,
normally specificity 0 means it should be good and sensitivity is 1. So it should be good.
not really.
But but to what extent, that's what.
Okay, so here, okay, I think I have not shared my screen. Second. Okay, so this is your ROC curve, TPR or specificity, FPR or 1 minus sensitivity, 1 minus specificity. So this point over here is 1 comma 1, which means 1 minus specificity equal to 1 implies specificity is 0 and sensitivity is 1. So what it means, your let us say it's like this. So your true positive,
The equations that you wrote.
sorry, my bad, it should be other way around.
Yes.
Yeah, it should be over here. Tp upon Tp plus Fn and Tn upon Tn plus Fp. So it means that false negatives, so if you take it over here, Tp is equal to Tp plus Fn, which means that false negatives are 0 and true negatives are
0.
okay. So how will you see this as a threshold over here? False negatives are 0 and true negatives are 0. So if this were the case in which your negative class was given like more importance, so all the true negatives are getting misclassified as false positives. So in this case, if your model, if your problem expects you to have certain importance for negative values, so in this case this particular threshold over here is not that appropriate. It will correctly classify all the true positives, like it will not have any false negatives, which means that all the true positives, all the positives are getting classified as positives. Okay, but the trade-off is like the negative ones are totally getting misclassified. So that's what it means over here. So it was just one inference that was asked, like what can you infer from this? So the true negatives are 0 and false negatives are 0, which means that true positives are 1.
This will happen in the case where the threshold is taken all the way from left.
Yeah. So it will be like over here. So all these positive classes are getting correctly classified as positive, but all the negative ones got classified as positive ones. Okay, that was all about it. So TPR equal to 1 correctly detects all the true positives, FPR equal to 1 fails to detect all true negatives. Okay, I think this is the last question. Which one is better, model A or model B? We just discussed this. Yeah. So that's the answer, correct answer. Model A is correct because for a given false positive rate, you have higher true positive rate for this RAID model over here. So these two can be any two model, like two different logistic regression models or logistic regression model or neural network model or anything. So this is to compare the models. Okay. So this was about the theoretical part of it. Let us go and see some Python example.
Actually, I wanted to ask if I use spider for this, will it be okay?
Yeah, that's totally fine. Like it's up to you. Like whatever is more comfortable, then you can go ahead with that. It won't change. The only thing is like you'll have to install Spider on your system, and then it will be only accessible. Like if you save certain files on your system, you may not be able to access it somewhere else.
Yeah, I have installed Python.
Spider.
Spider I have installed. It's easy to install through
Yeah, yeah,
Anaconda.
yeah, yeah.
Uh, but what about the libraries? I mean,
You will have to install your libraries on that, like on your system. So you will have to do pip install, like pip
okay.
pip install and the library name, whatever you have to install. So you can search it, like if certain library is not available, for example, let's say numpy is not available, numpy, you will get an error. Like if you try to import something in Python which is not there installed on your system, so you will get this error, module not found or something like that.
Okay.
So if you just go numpy or any other library, say, so basic thing is pip install the library name, but in certain cases it may not be straightforward, like if scipy is there or sklearn is there. So it's actually called, the library is called scikit-learn, but to install it you'll have to have this some sort of a command over there. So it depends on library to library, like what is the name of the library that they have given for the installation. So you'll have to just go to the documentation or any forum to see how to install that library. It will be given in this generally in pipei.org.
Okay.
Yeah. So
Okay.
yeah,
Thank you.
but one more issue, like one major issue with Python is that every library gets upgraded
Yes,
over
yes,
time.
very soon.
Yeah,
Yes.
so there will be version dependencies. Like if you are doing like it, we encounter this problem a lot. Like when in our research, like we need to use, like we need to build certain machine learning or deep learning models using tensor. There is a library called TensorFlow.
Thanks. Mhm.
Yeah, and TensorFlow supports certain version of like certain version of TensorFlow supports certain version of NumPy and certain version of scikit-learn and so on. So that creates a lot of problem. Like
Problem.
yeah, so version dependency is something which is there in Python, and you need to take care of it. So one ideal way is to create one virtual environment. So
Okay.
there is something called as virtual environment in Python,
Mm.
VENV. So it creates one environment and you install your libraries in that, such that so that it is not globally installed on your root directory, but in some virtual environment. So you can just activate that virtual environment and install any. So you say you want to use NumPy version 2 for certain application. So you can create a virtual environment for that application and activate it, and you work in that. And then when you want to work on some other application which needs you to install another version of NumPy, so you can go create a separate virtual environment for that and then install that version of NumPy in that. So you don't have to like install NumPy globally. You can use different versions of NumPy in different
Versions. Okay. In different environments.
yeah,
Okay.
in different virtual environments.
Mm.
Yeah, so that is one advantage of virtual environments, and it is recommended also, like if you are dealing with so many libraries, so there will, if, to avoid all these clashes, that certain version not supported by some other library certain version, so it is better to create these virtual environments and work with that. But whereas in Colab, uh,
So you don't have to worry anything.
it you may have to in certain scenario.
Yeah, when the library, I mean, the data set is too large, there it's a problem.
Not really. Like even in Colab, like if you see, there will be certain version of NumPy or certain version of TensorFlow that might be installed. Uh, like it is actually installed on Google's cloud or server. So you are running all your code on Google's cloud. But if your program needs certain specific version of TensorFlow or NumPy or SciPy or any other module, you will have to specifically install. Like so,
It's
in
that.
Colab also there is you can do pip install, but you will have to have this exclamation over there.
Okay.
So pip install, so let me, there is a library called mxnate, I think, yeah. So if I do pip install mxnate over here, so it will try to install this library on Colab, which is not already installed in Colab actually.
Installed in Colab, right.
Yeah. So you can see that when you install a certain library, it will also try to install its dependencies. So you can see like there are other libraries also are getting installed over here, GraphViz and also on. So this is a problem. Like if you install mxnate and it will or any other library, it may also install certain version of NumPy as well, because NumPy might be
Okay.
one of the dependencies, and it will overwrite your existing NumPy installation. If so, that's why virtual environment is the better option to work with.
Thank you.
Yeah. Okay, so we saw logistic regression already. So let us see ROC curve, like how we can do it. So I'm importing all the necessary libraries. I'll be sharing this with you, so I won't go into the details of it. You can play around with it, and if you don't understand any library, simply just copy something and then search it online. There will be like a number of forums, and you can make use of AI language models over here. In this case, I won't recommend to refer to a like AI language model or GPTs for learning all the things. Like it may also give you incorrect information, but in this cases, like if you want to understand some code which you are not able to do, or want to rectify some problem or resolve certain bug in your code, so for that, yeah, you can definitely use GPT and get solutions. But important is whatever output it is giving, you should be able to understand it. You should not blindly take that output and then use it. So you should try to understand what exactly the problem was and how it tried to resolve it, and learn accordingly. So that's what I would recommend. Don't use GPTs blindly, but try to verify the answers from some other sources. Okay, so here I am importing pandas, which is used for creating data frame, that is storing the table, numpy for numerical operations, stats model for building logistic regression models. Here actually like another function module is used, sklearn. In the other cases, we use this logit function in the previous case, which was in stats model. In this case, we'll be making use of this logistic regression, which is available in sklearn, scikit-learn library. And there are these metrics, accuracy score, confusion metrics, and classification report, which will give you all this specificity, sensitivity, and so on. Okay, so let us first read. Simon so dot XLS, which is containing the data from this company of spending, card, and coupon. Then we have this. So once we have this data frame, there is a function called describe, which gives descriptive statistics of the data set, that is like the mean, standard deviation, minimum value, 25 percentile, 58 percentile, and so on, 50% and so on, and maximum value. So this is just for information, like you may not need it. And there is this function called unique, which will give you the unique values in that particular column. So here data, we are trying to access this column coupon, and in this coupon we are trying to find the unique values. Similarly, if you want to see in spending, column spending, let me just try over here. So you will get a list of all the unique values in this particular column spending. Okay, so here just to verify, we have two unique values, 0 and 1. That is 0 is like do not allot the coupon, or 1 is like provide the coupon. And then for each of these zeros and ones, like values, what is the count? So there are 60 people who were allotted coupon, and 40 people who who were not allotted coupon, and 40 who were allotted coupon. Now, as we did earlier, we are taking the independent variables into x and dependent variables into y, and then in this case what we are doing, we are dividing this data into train and test using this function train test split. So, you are giving this x y over here, test size 25 means it will divide the data into 75% training, that and 25% as test data set. So, x train will contain 75% of these variables as training data to train the logistic or build the logistic regression model, and the corresponding labels in y train. X test will contain the 25% of the data, remaining data, and the corresponding labels in y test.
I have a question. Should not we try to maximize our test size?
Generally, it is taken 80-20 split, but it depends on the problem at hand. Like if you want to see the robustness of your model, like on a larger test set, so yeah, you can have like less number of training samples and then more testing samples.
Basically, we have been given the data for this sample set, right? So if we are going to train the model on the whole of it, like the 100% of it, and then test it on 100%
that
of
is
it.
not recommended because that leads to data leakage. There is a problem called as data leakage. Your model is learning the data, right? So you want to test it on unseen data, like how well it performs. So suppose like I am training a logistic regression model to identify cancer or not cancer, and I train it on some available data.
Let's say if in X train I take the 100% and that also has the results also, like if the person is having cancer or not.
Yes, so that is true, but when you have to evaluate it, you will have to evaluate it on unseen data, because unseen data may be having certain outlier or some other values which are not seen in the trained data. So to have that robustness, to take care of that, or to tune the parameters of the model, like in this case there might not be like much need, but if there is something like some neural network model is there, say, so it should learn, it should be able to identify unseen data or perform well also on the unseen data. So you will have to restrict its parameters or hyperparameters such that it performs well on the test set, unseen test set. So the information should not get leaked, the test set information should not get leaked into the training of the model. That is the main
This problem is called the leakage problem.
yeah, data leakage. So data leakage is something that you need to avoid if you are doing any sort of if you are building any sort of application.
Okay.
Yeah.
Another question: this random state, is it randomly set or because
yeah, so something yeah, so this is called as so it is also called as random seed. So internally it does random value, it randomly assigns x train and y train, like x test. So depending on the seed value, the answers will means the allocation might also be different. So for this particular random state 42, the train test split will be different, and if I give some 4 over here, so it will be different. So why it is necessary? In this case it can be anything, that is fine, but when you are so in certain scenario you may have to see like how, if your train set is changing, how the predictions of the models are changing. Let's say like you train you have 10 data points, out of which you take some 8 data points for training and 2 for testing, and let's say these 8 data points are all similar. So in that case it may not be like a very robust model. So for that you will have to try out different seed values so that the splits are different. And there is something called as like for a given, if you have set a seed, You can also do k-fold cross validation. So let me
Yes,
just
cross validation. Yes. 5 or 10, tenfold cross validation. So that
yeah.
will automatically set or what?
So what it does, okay, let me just explain what exactly happens in k-fold cross validation. So you have your data, you let's say it is five-fold, so k-fold, here k value is 5. So you divide the data into 5 parts and you take one part as test and remaining 4 part as train in one case. Then this is case 1. In case 2 you take this 4 parts as train and this particular part as test and so on. So you take this as test, remaining as train, this as test, remaining as train, this as test, remaining as train, and so on. So you have like 5 different test train and test sets, and you build model on this and try to evaluate a model, build the model on the train sets, and evaluation will be done on the unseen test set. So that's the advantage of k-fold cross validation, that your model gets trained differently on different data sets, and you can see like how well that model is, like how well it performs on in different scenario.
So is there a command or argument for this? For
K-fold cross validation, there is another library actually, like in sklearn I think there might be something for let me just check it over here. I used it long back. Yeah, sklearn there is this yeah, stratified k-fold and k-fold. So yeah, please look into it. Like I have not used it for a long time. So sklearn model selection dot k-fold. So you will have to specify the number of splits you want to have and shuffle, like if you want to shuffle the data and on. I mean shuffle in the sense like you will be given data in certain format. Let's say you have 10 numbers 1 2 3 4 5 up to 10. So it will first of all shuffle it and then split it. And random state is like what I said, like for a given seed it will split in a certain way. So you may try out with different seed values as well for these k folds.
yeah, yes.
Yeah.
Hi, thank you.
So
One more thing I wanted to add, like my understanding is that random state is given so that we can replicate the
yes,
same
yes,
random set.
yeah. So it is mostly for the reproducibility of the results. So when you publish some research papers actually, so you need to specifically mention we generally upload all our codes to online repositories like GitHub. So we need to specify uh, like what seeds we have used, what kind of machine we have used actually, like on what system we ran our code, like the system specifications also need to be provided so that the other people can reproduce those results. Because one issue is that if you change the seed value, your results will drastically change, because the initialization of the model or the way the train test splits are getting generated, so this will be different. And also it depends on your system's architecture, like if I am running something on my MacBook or on a Linux machine, so answers may be different like for a given seed. So I encountered similar issue while running some code in MATLAB programming. I was getting certain values for a given seed on my MacBook and some other values on a Linux system. So you will have to be very specific, like if you are doing some research, you need to specify all the things clearly, like what machine you have used, what seed value you have used, so that the results can be reproduced.
Oh, okay.
Yeah. Okay, so let us move ahead. Yeah, so we have this train test split. Let us see this X train. So X train is having this. So we had like around 100 such entries, and out of that 100 entries, some 75 entries are over here shuffled all together. and then the corresponding labels will be in this. So it is having spending and card values, and here you have the corresponding label 0 or 1, like is the coupon was allotted or not. Now there is this function called ravel, which actually flattens the array. Like you have this in tabular format over here. It kind of like creates a list out of this particular, or numpy array out of this particular table over here. So it is just to flatten it, and then you pass this particular thing ytrain dot ravel and xtrain into linear regression model. So here you are initializing the model, sorry, not linear regression, logistic regression, and there is this solver. As you saw, like this is one optimizer, optimization algorithm that is being used internally by this logistic regression model. You are initializing one object of this particular logistic regression class. It's into the object oriented programming. So for those of you who do not know, don't bother about it. It's like just creating one instance of this logistic regression model with this particular optimizer, and then you are fitting the data using this particular object over here, or variable lreg.fit, and passing this xtrain and the flattened ytrain. This is needed, actually expected by this model function. That's why this transformation had to be done over here. So if you get certain error at certain point, you can definitely look into the online resources. Okay, so now once the model, so this will train the model, build the model on this data, and now we will here what we are trying to do, giving the trained data itself as input to predict. So lreg.predict will predict the labels for the training data points over here, and in this case we are trying to predict the labels for the test data points, the 25 points. So here these are the 75 points which were actually used for training, and these are the unseen data points, test data points. So using this, so once we have this, we are computing the probability values for each of this. So probability of getting this particular label over here, that is the sigmoid function. Internally it is computing that and giving us the output for each of the train sample train data point, and similarly we will get it for the test data points. And now you will have to set some threshold to classify them as belonging to class 1 or class 0. By default, I think the model uses 0.5 as threshold. Let us see the model summary over here using this sm.logit. So you can see the spending is the spendings coefficient and the cards coefficient over here. Similar is being computed internally by this logistic regression module that we have used. So to compute the accuracy, so on the test unseen test dataset, you are passing the actual labels of test and the predicted labels which were obtained using the logistic regression model. So here you can see that 76% of the labels were correctly identified, and there were certain misclassifications that you can see using confusion metrics. So here, like you can see, like from class 0 or 1, it depends on which label it is. So from this particular class, 15 of this particular class values we are getting correctly classified, and 1 got incorrectly classified. Similarly, 5 of this particular second class got incorrectly classified and 4 correctly classified. Okay, let me show it to you on iPad.
Just a query. This accuracy underscore score, it's like creating a for loop and testing the arrays, both the arrays against each other, right?
Yeah. So what is happening over here? So you have the actual labels over here, pi 0 1 0 1 0 0 for these data points 1 2 3 4 and so on up to say 25, and you have predicted ones as say 0 1 1 0 0 0 and so on. So how this 0 is getting correctly classified as 0, 1 is getting correctly classified as 1. So it kind of computes the confusion matrix internally, like how many of zeros, so actual, predicted, how many of zeros are getting correctly classified as zeros, that is to positive, say let's say if 0 is the positive class, and how many of ones are getting correctly classified as ones, and then how many of 0 are getting incorrectly classified as 1, and so on.
Right. So if I had just two arrays of equal length, I can just put in accuracy underscore score and
Yeah,
see if they
so
match.
yeah, so yeah, you will get the accuracy over here. So what it is doing over here, accuracy score, wait a second. Yeah, so it is internally trying to find like how many zeros and how many ones out of the total 25 ones are correctly classified as zeros and ones. So here I'll count the zeros getting mapped to zeros, count of zeros to zeros, plus count of ones getting mapped to 1 upon total count.
Oh, it only works on zeros and ones.
Yeah, so this is, yeah, so I wanted to show this. So accuracy can also be computed as true positive plus true negative upon TP plus FP plus TN plus FN. So this will be your total data points, and these are the correct data points, means data points that are correctly getting classified.
Right.
Yeah. So that's what is happening internally in that accuracy check. So yeah, this is one thing. Accuracy is one measure, TP plus TN upon total number of data points. You can consider it as N. And there are other measures as well called precision and recall. I'm not sure if this was covered in the course. Recall is nothing but sensitivity. However, precision has a different formula. So it is TP upon TP plus FP. So it shows like out of all classified as positives, how many are correctly classified as positives. So out of all the positives, how many are actually positive. So precision is used in scenario wherein you have like a lot of negative examples. Say you are trying to identify or classify patient into as having a very rare disease. So there will be like very less number of patients in that case which are having this rare disease. So in that case your negative examples will be too high. So for that case precision is preferred, and sensitivity you already know, recall is nothing but sensitivity, and there is something called as F1 score. So there will be some trade off over here. So F1 score is actually harmonic mean sort of precision and recall. So please check that later whenever you have time. These are like different metrics that are used to evaluate your model performance. Okay, so you have the score, you have confusion matrix now. So again this we are using this Ravel function to flatten this. So this will be 15, 1, 5, 4. So you will get true negative, false positive, false negative, and true positive over here. So this will give you the classification report, this particular function. As I said, precision, recall, F1 score, and support. Support, I am not very sure exactly what they mean by support. I have not used it, but yeah, precision, recall, and F1 scores are these three metrics are used a lot in research. And again, then finding accuracy using this formula, TP plus TN upon TP plus TN plus FP plus FN, that is correctly classified upon total number of data points. So it is same as what you are getting over here, accuracy score. Again, specificity is Tn upon Tn plus Fp, sensitivity is Tp upon Tp plus Fn, and so on. And then there is this code for generating ROC curve. So I'll just quickly run it over here and leave it to you, like you can explore it in detail, like how this particular plot is getting generated. So yeah, please play around with this notebook. So this is for the train set and this is for the test set, unseen test set. Okay, so please see like and infer something from this. Like you can see that even if it is trained on this data train set, it is still making a lot of mistakes in the classification, whereas on the unseen test data it is performing well. So there can be some exceptions as well, like, so please check this. You can import some other data as well, like whatever data you are working with, and then build logistic regression model on that, and then see how the ROC curves look like. Okay, so here is manual thresholding. Like we got this probability values right over here with respect to the logistic regression function model for each of the data points. So we have this probability scores. So now if we have a manual threshold, so internally I think it was doing classifying as zeros and ones using threshold as 0.5, but you can set the threshold as some random value over here between 0 and 1 and then classify this. So what is happening over here, np.where will see wherever the array is greater than or equal to the threshold value, it will be assigned 1, else it will be 0. So if you see over here the ones and zeros, so ones were assigned to the data points which are having probability value of more than 0.35. So if I change this over here, let's say 5, so you can see the change in the values. Okay, let me just show it over here. .35 and 0.5. So you can see the difference. And let me print this array as well. So you can see this particular value is greater than 0.5, so it is assigned 1. This is less than 0.5, so it is assigned 0 in this case, but it is greater than 0.35, so it is assigned 1 over here. So you can set a manual threshold and then predict the class and then compute all these things, confusion matrix, true positive, false positives, and so on for different thresholds manually, and find out the base threshold. So I leave it to you, like you can experiment, play around with this notebook. I'll just add it to the shared drive folder. So yeah, that's it.
Should not we get the best threshold from ROC?
Yeah, so actually there is a code for that as well. So it was also, okay, let me just show it to you. So there is something called as, so in this case this is a plot of TPR versus 1 minus FPR. So wherever this particular so in the TPR, the actual ROC and TPR versus 1 minus FPR, so wherever this crosses over here, that is the point which is the ideal point in which you will get a minimum like the balance
Errors.
will be there. Yeah, errors will be there, minimum errors in the sense like the balance will be there. So yeah, please look into it like in detail later. So yeah, you can decide upon the threshold based on this particular intersection of the two plots.
Okay.
Yeah, here is the code to do that, like wherever that particular thing is having the minimum number of misclassifications, so that is the best one. Okay, so yeah, you can play around with this notebook, and please let me know if you have any queries relating to these topics in the next session. Okay, so that's all for today. Thank you all for joining.
Thank you for the session.
Yeah, thank you so much.
Thank you.
Just a small question before you go. Like, how long have you been doing regression and ANOVA and this Python thing?
Actually, I have not used ANOVA and all like in my research analysis, like whatever analysis I do. What I work with is I work in the field of bioinformatics, and basically signal processing guided machine learning applied to biological signals. So I work with genomic signals and EEG signals that are electroencephalogram signals collected by placing electrodes on your scalp. So
Okay.
we try to analyze these brain signals and signals from DNA, RNA, and so on, and try to extract certain information from them. So I use specific machine learning models, deep learning models to do so. But the pre-processing needs to be done using signal processing. But for statistical tests, I have not as such used as many statistical tests as mentioned in the course over here. But yeah, definitely we do need to see the statistical significance of the results that we'll be getting.
Okay.
Yeah, so it depends on the problem at hand. There is some, it's not in the course actually. So in the case of EEG, we use a statistical test called permutation test, which is a non-parametric test in which you don't assume any model parameters. So for T test, Z test, you have this T distribution, Z distribution, right? So in the case of permutation test, it is like based on the permutation, like you kind of like interchange the labels, randomly assign the labels to the values, try to classify, and then change the labels again, and then classify and change the labels, classify, so on. So you try to build a distribution of scores based on these randomly assigned labels, and then see like if the labels are correctly assigned, how is your classification, like how well your model is classifying, and based on the threshold or like the p value, you will see if your null hypothesis, if the model is actually working well or not. That's what we do. Like permutation test is something that we use, but it depends on the problem at hand. Like whatever problem you have,
Okay.
yeah, you will have to use appropriate test over there.
But how long have you been doing this? Like,
Yeah, it's been like I'm in the 4th year of my PhD, so yeah, it's been.
so you started from the first year itself?
Not really, like, but yeah, recently, like 2 years back, maybe, like it was the first time I TA'd for this course online.
Nice.
Yeah.
Nice. Thank you for sharing.
Yeah, thank you everyone for joining, and thank you for asking questions, because I am also learning a lot through this. Like I myself need to learn first and then explain it to you. So if I am making any mistakes, please do feel free to correct me. Okay, so I'll end the call now. Thank you.
Thank you.